All of the houses are oriented completely south, so that's south. And you can see it's designed so that the overhang protects the house from heating up too much when the sun is high in the summertime, and yet in the winter when the sun is lower, the sun can penetrate further into the house. Okay. So the overhang on both levels is designed to do that. And you can see where this shadow is right there. So the sun is heating up the cement slab of the house, so we get passive solar gain. Okay. And in the summer, since the sun's higher, it's shaded and it's protected. Here's the pipes that go down into the floor for the radiant heating, right? And you can create it so that there are different zones to heat up certain spots. Like my one neighbor up here has one area that he wants to use to store food, so he doesn't heat that area, right? Okay. So each of those is in a different section of the floor. And you know what radiant floor heating is?
It's like running water and stuff through.
Right. So the water helps to maintain, or the sun heats up the floor, and that heat gets captured there, and vice versa. You also have the sun from on the roof heating up that comes down here and heats this, so it works both ways. They have the solar, and they actually have two different panels here. One is for the regular panel and one is for the solar stuff. And depending on how you hook it up, certain parts of the house can be can be battery backup. Here's a battery, and other parts don't have to be. So if the power goes out, you certainly want the power to be routed to your refrigerator, maybe your computer. It depends, right? So generally, across the board, we produce more electricity than we use. Okay, but again, that varies from house to house. Like, some houses have a smaller system than others. We have a minimum amount that's required, but some have used the minimum and some have gone way more than that. So we have the solar backup. We also have, there's an automatic, like you can imagine if the power goes out, we have to automatically shut off the power from the solar because we don't want to zap anybody out there that are working on the lines, right? So it's an automatic thing. If the power goes out, we immediately stop sending electricity into the grid. All right, so there's that. And then the solar hot water, so the antifreeze, it's up, I'm sorry, the solar PV, this is the solar PV, I'm getting mixed up. The solar hot water uses antifreeze, and the antifreeze circulates through the hot water tank. Antifreeze. Okay.
Is it like a certain kind of antifreeze, or?
I don't think so.
Just like run of the mill?
I think so, yeah.
Okay.
Mm-hmm. We have a policy that says our primary heating source is solar, which basically means passive solar, right? And PV. Secondary can be something like, well, the secondary is actually gas. Then the tertiary, you're allowed to use wood stoves, but it's not supposed to be your primary source of heat. Okay. So we do have a few people who actually have wood stoves, but the primary heat is supposed to be solar and gas. The water from the septic tank is anaerobic, right? No oxygen. Right? Comes in here, it comes into this first. This is, it's got a bubbler at the bottom, and you've heard all this before already. So it actually is changing the environment from anaerobic to aerobic. And it's just like, a bubbler would have in, your fish tank or whatever. Right? Put oxygen into it, which allows you to change the type of bacteria. Right? And that's sewage. That's basically raw sewage right there, right out of the septic tanks. Did you get that? And it really doesn't smell like much at all. And then from there, it goes over to these tanks, which are the settling tanks. And in the bottom of this, we have this like a cement funnel. And so the particles settle down into the bottom, and then there's activity going on here, but it's basically just a settling tank. From here, the water goes straight into the ground. When I was standing in the bottom of this before we put the gravel in it, it came up to here on me. Okay, so what's that? 4 feet down is right, and the whole thing is lined with this, and then filled all the way from the bottom with this. It was very special. You had to have the right size gravel, and it had to be the right kind. Okay, so it was all filled in. The water here trickles down that way through all of them, through the marsh. This section, it's like a big bathtub, really.
Yeah.
Okay. And when it gets to the end, it gets pumped back up here. Okay. So what happens is the roots of all of these plants are actually what processes most of the waste. Right. So the bacteria on each of those roots is what's cleaning the water. Right. It's slightly tilted down so that all the water goes that way slowly. Right. And these white pipes are simply to keep the tough surface a little bit wet. That's what that is. Okay? So if you were to go, it's not too far down here that you start getting to water. At any rate, it's not far down, especially if we go over there, I can show you. So from there, in those two black things are pumps. The water from there gets pumped back over here. And in the summertime, these little guys multiply and fill. I mean, it's like this, right? And the roots of those water plants it's just a gigantic mass that are processing all the waste.
What kind of plants are these?
Well, what you do is you plant something that is going to like having feedback, right? They're all different kinds of things, canis and elephant ears, but whatever you put in here, if it likes it, it sort of thrives. If it doesn't like it, it dies, right? And there's a lot of different things.
And all you do with the water that comes out of here is flush the toilets?
Yes. Yes.
So you have special plumbing that just goes directly to the toilets?
Yes. Yep. So from here, the water goes into the secondary marsh. This is sort of the final. This little bathtub, little section is separate from that one. And from here, it's the same exact kind of plants. It's just that the water's now cleaner, right? And then from there, it goes out there, and I'll show you that. But yes, when the house is plumbed separately so that it's just for toilets, and we do every single week we send a sample. We do samples of the water here and send it to a lab to have them checked for all sorts of things, chloroform and all sorts of different things. So we have lots and lots of data.
What kind of additional treatment would it take to use it as just drinking water?
It's none.
It's just the personal
It's
hang up?
just the state requiring us not to not allow us to do it. So, and people's attitudes towards it.
Yeah.
But no, it's fine. It's checked every single week. We check it. There's a turbidity meter, which checks the particulates in the water, and if the water is not clear enough, what that means is that there's too many particles, and bacteria can hide behind the particles, and the UV light won't be effective. All right. If the water is clear enough, the UV light will zap whatever's left. Okay. If it isn't clear enough, the turbidity meter indicates that, and the water gets pumped back. Okay. So once it goes through the UV light, it goes then into this tank, which is just a storage tank. This tank also circulates back through the UV light, right? This water then either goes to the houses for flushing toilets, or if there's too much of it, it goes out to the fields over there where there's a drip field, drip irrigation kind of thing, right? So if there is not enough of this water, which doesn't happen unless some pump breaks or whatever, then the other well water kicks in.